Okay, hi. Now we have another problem here to solve. We have to determine a line equation that is parallel to this one, but not any parallel, because we have infinite parallels. It must be such that it must pass through this point. So what do we have in here? Let's just put it like this. So we just have a line like that, and this is going to be y equals x minus 6. This is our starting point, and we have to pass this line. We must create a parallel line to this one, but not any parallel. It must pass through this point in here, and this point is going to be -3, 2. So we have to do this. We have to make a parallel, but it must pass through these points. Let's call this R, this S. And what is the first thing we have to accomplish in here? Well, we have to understand first what does it mean to be parallel. Okay, to be parallel, it means that this coefficient in here, it must hold. Okay, so this is the whole point in here. If we had y equals -2 plus whatever, we would have to keep this -2 in here. That is the whole point in here. So this is the line, okay, tangent, okay, the slope, right, of the line. For instance, let's suppose we just have this arrangement. We have a line, for instance, this R, and then we have another line in here like that, S. Well, let's just make the tangent of those. This is going to be the tangent of R. Okay, let's just call it M1. Okay, and this is going to be the tan, okay, of S, and let's just call this one M2. So we have our line S, which has inclination M1, and we just have our line R, which has inclination M2, and it's clearly that M2 is going to be bigger than M1. Okay, and because they are different, they are not parallel. So the first thing we have to accomplish in here is, what's going to be that line? Well, that line is going to have to follow this. Y is going to be 1x plus b. Okay, this is going to be our equation for this line. But why b? Well, because when you just make y equals x plus something, because the coefficient, it is the same, it is just 1, okay, we can be sure that it's going to be parallel. Well, let's trace another one here. Y equals x plus b2, this one. Y equals x plus c. It doesn't matter, okay? Any coefficient in here. Whenever we change this coefficient in here, the c, we are going to have a different parallel. And what happens if we change, instead of writing x, maybe -2x or -3x, or even y equals 7x? Well, whenever we change this number in here, which is 1, it's not going to be parallel anymore, okay? So to be parallel, the first thing you have to accomplish is it must be 1x, okay? The line tangent, the inclination of that line must be the same. Okay, now we have this equation. Let's just put it here. Let me just take the line. Let's just write right here. So how are we going to solve? Well, we have this line y equals x plus b. It can be anything, okay, but it's going to be parallel. But if that line is going to pass in this point, it means that that line is representing this point. And if that line, okay, that equation represents this point, it means that when we substitute those points in here, the equation must hold. So let's just do it. So 2 equals minus 3 plus b. Remember, when we just take the 3 and throw to the other side, it changes the signal. So it's going to be plus 3 plus 2 equals b. Therefore b equals 5. So we have just determined that b is 5. Therefore our equation is going to be y equals x plus 5, and that's it. Okay, that is our equation that we're looking for. It must have the same coefficient in front of the x because it's parallel, and to determine the value of b we just have to plug in that point into this equation, and then we determine b. Okay, and that's it for the equation. Thank you very much.